So welcome back to our notes for polynomial long division, and we're in example 2, dividing with linear divisors. And the three steps that you want to follow when doing a polynomial division, long division, would be listed up here at the top for your reference. Step 1 is to write in long division form, and don't forget to put in zeros for any missing place values. Okay, so in example A, when I look at my numerator here, that's my dividend, I have a cubed place value, an x squared place value, a linear place value, a constant place value. All those place values are accounted for, so I don't have to worry about missing place values having zeros. But in example B, notice I go straight from an x cubed to the constant. So in B, I'm going to need to remember that tip to put in zeros for missing place values because I'm missing the x squared place value and the linear place value. Okay, but in example A, there's no missing place values, so I would start with my divisor, 3x plus 2, and I'm going to divide that into the dividend 3x cubed plus 2x squared minus 12x minus 8. Okay, and that goes under my division bar. Okay, so now I'm gonna, in step 2, divide as you do with integers, remembering to distribute the negative when subtracting. Okay, so if I follow that long division algorithm, I focus on the first term in my divisor and the first term in my dividend. And I ask myself, how many times will 3x divide evenly into 3x cubed? Or you could think of that as 3x times what is 3x cubed? And the answer would be x squared. Okay, so if I multiply x squared from my quotient times my divisor, I have to distribute. So x squared times 3x is a 3x cubed. X squared times positive 2 is a plus 2x squared. Okay, and then I'm going to draw my line and change the sign, and I'm subtracting this whole binomial here. So that means I'm distributing the negative to the 3x cubed and also to this positive 2x squared. So I'm subtracting both of those, right? That's what this tip up here to remember distribute the negative when subtracting was reminding me to do. So when I do that subtraction, 3x cubed minus 3x cubed is 0. Those cancel. Then 2x squared minus 2x squared, that's also 0. So those cancel. And then I'm going to bring down my next term, which is a negative 12x. Now, if my divisor is a binomial, I have to have at least 2 terms to divide into. I need a binomial. So I'm going to bring down my constant as well so that I can divide 3x plus 2 now into negative 12x minus 8. So I'm asking myself, what do I multiply times 3x to get negative 12x? And that answer would be a negative 4. And I line that up with my constant place values in my division, and then I distribute the negative 4 from the quotient times the divisor. So negative 4 times 3x is a negative 12x. Then negative 4 times positive 2 is a negative 8. And I'm going to draw a line and change the signs. And so a negative times a negative, right, makes this a plus 12x. Then a negative times a negative makes this a plus 8, right, because I had to draw the line and subtract both terms of that binomial. And now when I combine like terms, negative 12x plus 12x is 0, those cancel. Negative 8 plus 8, that's also 0, those cancel. And I'm left with a remainder of 0. Okay, step 3 reminds me about the factor theorem, which we just learned says that if the remainder is 0, then the polynomial can be written as a product of factors where the divisor is a factor and the quotient is a factor. So if I started with my standard form, which would have been the dividend, so y equals 3x cubed plus 2x squared minus 12x minus 8, and I got a remainder of 0, I now know that my divisor, which was 3x plus 2, times my quotient, which was x squared minus 4, that would be a way that I could represent that same polynomial in a factored form. But it's not completely factored because x squared minus 4 is a difference of perfect squares. So if you recall from Algebra 2, we can factor that further, right? 3x plus 2 is not going to factor further. That's a linear factor. But x squared minus 4 factors into x plus 2, x minus 2, since it's a difference of squares. And now this would be the completely factored form of my polynomial. Okay, so let's try example B together. Going back to step 1, we're going to write in long division form, putting in zeros for missing place values. And we do have some missing place values here in example B. So when I divide x plus 2 into my dividend, x cubed, I have 0 for my x squared place value, and I have a 0 for my linear place value, and then the constant is 8. Okay, and I want to have those zeros for my missing place values so that I can keep things lined up as I'm dividing. So I'm going to ask myself, x times what is x cubed? And that is x squared. Then I distribute the x squared from my quotient to each term in the divisor. So x squared times x is x cubed. X squared times 2 is a plus 2x squared. Okay, then I'm going to draw a line and change the signs, and I have to change both signs because I'm distributing that subtraction to both terms in the binomial, and then I'll combine like terms. So x cubed minus x cubed is 0, those cancel. 0x squared minus 2x squared is a negative 2x squared. Then I'm going to bring down my next place value, which is a 0x. And then I repeat that algorithm. So x times what is negative 2x squared? That answer would be a minus 2x. Then I distribute to the divisor. So negative 2x times x is negative 2x squared. And negative 2x times positive 2 is, whoops, wrong sign, is a negative 4x. Okay, then I'm going to draw a line and change both signs. So this negative becomes a positive and this negative becomes a positive. Okay, then I'm going to combine my like terms. Negative 2x squared plus 2x squared is 0, those cancel, and 0x plus 4x is a positive 4x. And then I'll bring down my last term, which is the constant 8, and repeat the algorithm. So x times what is 4x? That would be a constant of positive 4. Then we're going to move this down out of the way. Okay, then we're going to multiply. So 4 times x is 4x, and 4 times positive 2 is a positive 8. Then we can draw a line and change both signs. So both of these now will be subtraction and combine like terms. So 4x minus 4x is 0, and that cancels. 8 minus 8 is also 0, which would be the remainder. And in step 3, it tells us that if the remainder is 0, that polynomial can be written as a product of factors. So I started with my standard form, which was x cubed plus 8. And then since I got a remainder of 0, I now know that that would factor as x plus 2 times the quantity x squared minus 2x plus 4. And I want to check and see, will this quadratic trinomial factor further? So I would make my crisscross and see, are there factors of 4 that add to equal -2? And the answer to that is no. Okay, so go ahead and find some notebook paper or on a dry erase board and try to divide x minus 3 into 4x cubed minus 23x squared plus 30x plus 9. And then once you find that quotient, see if you can factor it completely, solve to find the zeros, and sketch the graph. And then when you're ready to check, you can resume the video. Okay, so welcome back, and let's try this problem together. So x times what is 4x cubed? That would be a 4x squared in the quotient. Then we're going to multiply 4x squared times x is 4x cubed, and then 4x squared times -3 is a -12x squared. Okay, then we will draw a line and change both signs and then combine like terms. 4x cubed minus 4x cubed is 0. Those cancel. -23x squared plus 12x squared is a -11x squared, and we'll bring down our next term, which is positive 30x, and then repeat the algorithm. So what do we multiply times x to get -11x squared? And that would be a -11x. -11x times x is -11x squared. -11x times -3 is a positive 33x. Then we're going to draw a line and change both signs. So then when we combine like terms, we'll have -11x squared plus 11x squared. That cancels. 30x minus 33x is a -3x. And then we bring down the next term, which is a plus 9, and repeat that algorithm. So what do we multiply times x to get -3x? That would be a -3. -3 times x is -3x. -3 times -3 is positive 9. Then we will draw a line, change both signs, and we end up with a remainder of 0. So that means that I can rewrite this polynomial in factored form as x minus 3 times the quantity 4x squared minus 11x minus 3. Okay, but that may not be completely factored. This quadratic trinomial might factor further. So the way I teach my Algebra 2 students to factor, it might be different than the way you learned how to factor quadratic trinomials. That's fine. You can use whatever method you're comfortable with. I'm going to just review the way that I teach factoring for those who maybe find this an appealing way to go about it. So in the crisscross and the box method, in the crisscross you put a times c in the top and b in the bottom. So a is 4, c is -3, so a times c would be -12. And then underneath in the bottom is the b, the middle term, which is a -11. And I asked myself, what are the factors of -12 that add to equal -11? And that would be a -12 and a +1. So those two factors go in the boxes on this diagonal. So I'll have a negative 12 and a positive 1, and each of those on that diagonal gets an x with it. Okay, then my first term in the trinomial goes in the first box. That's a 4x squared. My last term in the trinomial goes in the last box. That's my constant, negative 3. And then I'm just going to go across each row and up and down each column looking for the greatest common factor. So 4x squared and negative 12x, they have a GCF of 4x. Okay, then x and negative 3, they have a greatest common factor of 1. Up and down the first column, 4x squared and x, they have a GCF of x. And then second column, negative 12x and negative 3, they're both negative, so I can pull out a negative. And then their greatest common factor is 3. And the outside of the box then shows me how that quadratic trinomial factors as 4x plus 1 and x minus 3. So I can factor this further. So I have my original x minus 3, and then I have another factor of 4x plus 1. And because this x minus 3 from my factor box is another instance of the same factor I had before, that means it has multiplicity of 2. So I can put a square on that first factor. And this would be my completely factored form. So to sketch the graph, let's make a little graph here. And there we go, x and a y axis. And I have a real 0 at positive 3. So 1, 2, 3. And that would be an x-intercept. And then at negative 1/4, right, there's going to be another 0. So negative 1/4 is going to be real close to the y-axis. So the end behavior, since this is an odd degree and a positive leading coefficient, the ends are going to start down and end up. That's using my leading coefficient test. So if it has to start down and cross through negative 1/4, because that's a linear factor, then bounce at positive 3, because that's an even multiplicity, and end up, then my curve is going to look something like this. And that would be my graph. So the factored form, completely factored form, is x minus 3 quantity squared times the quantity 4x plus 1. That produces this 0 here at negative 1/4, another 0 at positive 3. It's crossing at negative 1/4 and bouncing at positive 3 because of that multiplicity 2. And then again, my end behavior I figured out from the leading coefficient test, where my degree was odd and leading coefficient was positive. So you're going to, on this last slide, answer the secret question for this lesson on your own paper, and be sure to upload it as the last page of your notes to Schoology. So the polynomial that you're going to divide is 2x cubed minus 7x squared plus 8x minus 3. Your divisor is 2x minus 3. You're going to do polynomial long division. Make sure you show all the work for that if you want to get credit for the division. And once it's divided, you should get a remainder of 0 for this problem. So if your remainder isn't 0, go back and try it again till you get that remainder of 0. Then you're going to need to factor that polynomial completely. So that means your quotient will be a quadratic trinomial that you need to factor further. Okay, then once you've got it factored completely, solve to find all the zeros, keep an eye out for multiplicity, and then use that multiplicity to sketch your graph. So if you have any bounces, wiggles, crosses, make sure those are indicated in your graph. Don't forget the end behavior using the leading coefficient test, and that'll put everything together that we've learned so far in this unit.